Hello everyone, welcome to our pre-calculus lesson 20. In this lesson we will discuss some further applications on linear functions. These are our today's agenda. First of all, we will discuss two quick models based on truck rentals and cost of driving a car. Then in detail we will discuss straight line depreciation, which will come up, you will see. And there are three situations from this same topics, similar kind of problems, all of them. Then we have some review. We have solved this kind of problems in our last class. This is linear equations from data, supply and demand math. So we just have put it here also, so that you can just review them and think about that. That's it. Then homework and homework review. So these are our today's agenda. Let's start. First of all, we have this. This is the thing. Our linear functions. Most of the things that will come. Let me show you first the problem. These are the problems that we will try to find out some linear function. Before we start this kind of maths, let's discuss some very simple situation. Suppose you have $50. Suppose you have $50. Then you decided in every week you will add $2 with this $50. You will add $2 with this 50. $2 every week you will add. Then if I ask, okay, what will be the function that will represent this money, the thing that we are saying, let's say in terms of week, what will be your total money after some couple of time, after some weeks, or how can you represent this thing in a equation, in a function? How can you represent this thing? So if you look at these things very closely, you will see that total, let's say total money, your total money will be what I said. I said $2 every week you will deposit, or you will add with this 50, so that your money increases. This is your target. So since every week $2 you will add, that's why you can write 2W or 2x. X is the number of week. You can start with this number also. You can say that, okay, I already have $50. Then add means, you are depositing, you are adding, you are gaining that money. $2 every week. Now for week you can write W here also. Some alphabet you can write, something, whatever you want, you can write it here. So this will be your linear model based on the situation that we set. And most of the real life application math is basically like this. So here, just the difference is here it is increasing. And if I say it now in some other way, if I say that, okay, all right, you have $50, same money. Since you have this money, now your plan is to spend it. Every week you will spend $3. Suppose every week you will spend $3. Then what will be the remaining money in your pocket? So that function you can write t equals to, you can think about it, then if it matches with me, then that's correct. Already you have 50, then every week you are spending, so money will decrease means minus. And how many dollar in every week? $3, as I said, per week. $3 per week. So like this. Now sometimes this kind of math, these maths we write it like this: minus 3W plus 50. Sometimes we write them like this, which is same. They means the same thing. And this thing also sometimes we write it like this: 2W plus 50. This line and this line, they are exactly same lines. They have no difference. Okay, mathematically there is no difference. And so this case the money is decreasing, and this case the money is increasing. If money increases, then the sign is plus. If money decreases, then the sign is minus. And the thing is, in the straight line, only there is these two type of maths. Sometimes you may think like, okay, maybe there are many types, or why I do not understand. Don't get confused. There is only these two type of maths. One case, money or something will increase. Another case, something will decrease. There is only these two type of thing for this linear modeling, uh, and the format is just only these two type. Okay. And if you understand this kind of progression, then basically these are good. Okay, let me tell you another one very important thing. uh, how you will understand if something is linear or not linear. How you will understand from the real life situation, how you will understand it. You will understand it if the increase is same every time, or if the decrease is same every time, then it is linear. Suppose this month you are getting, someone is giving you some stipend. Let's say this month he is or she is giving you $10. Next month also giving $10. Next month also will give $10, like this. Then this is a linear progression. Or if you spend this way, this is also linear progression. If the money decreases, increases, suppose this month someone give you $10, next month they give you $15, next month they give you just only $8, different, then it is not linear. Linear means if it increases, it will increase same value every time. And if it decreases, then it will decrease same value every time. Then it is linear. This is how you will understand which one is linear and which one is not linear, just by looking at or just by reading the line, reading the things. Now let's look at this situation. First you give a try to find out a equation for this two math. Then I will show you the answer also. So this is the answer of the first math. This is the answer of the second math. Let me explain. I hope you got it right. So you see, this is the starting value for this math. This is the some rental company. You have to pay this money no matter how many miles you move. Then for every mile you have to pay this money, $0.20 per mile. So that's why $0.2 per mile. Per mile means x, because they said that x is the number of miles, and c is the cost. That's why c equals to 0.2 plus 29. Now if you move 10 miles, then you have to put x equals to 10. If you move like 110 miles, then you have to write x equals to 110, then multiply it with 0.2, then add it with 29. Then you will get your like total cost is what. Similar situation for this fixed cost, etc., etc. The total cost is this, main cost is this, which is fixed. This is the fixed thing, and per mile, this is the cost. This is the thing for per mile. So that's why again similar situation, 0.15x, and then fixed cost is this money. No matter how many miles you go, you have to pay. This money is actually you have to pay. So that's the thing. That's why it is coming as a cost. So see, what is happening is the fixed thing it goes separately. Then per something, per month, per year, that money will come with the x thing. Okay, this is the technique. Per what, then that number will come for that x thing. Okay, with the variable, that thing will come. And if some number is fixed, that number will be just separate. Just this number you have to put it separately. Now we have this maths. We will discuss in detail. This is straight line depreciation. Depreciation means decrease in value. So you see, as I said, there is only two types of maths. One is increase in value, and depreciation means decrease in value. It will go down. It will decrease. Okay, it will decrease. How it will decrease? It is written here. A company office table was purchased for $500 and will lose all its value over 10 years, meaning it will depreciate by 500 divided by 10 equals to $50 per year. A company bought a table, okay, some table. Oh my god, this is so nice table. This is a joke. I do not know why I gave this line. Maybe the table is broken somehow. I'm kidding. So $500 they bought some table, and every year $50 will be the depreciation cost. Depreciation cost means if you use some facility, some product in the office, then you have to think that you are using some value of it every year. Okay, from the total cost. So per year, you see $500. So per year is 50. 50 plus 50. In 2 years, $100. In next 2 years, more $100. Total is $500 in 10 years. This is their thing, their question. This is the setup. Now, uh, maybe we will have to find out some model. Yes, that's the question. Write a linear function for the value t of the table that is x years old. So t will be the total cost. T will be the remaining money or the value that is remaining, something like that. So in this case it is t, but in some other case it can be y or something like that. So the question is t equals to what will be remaining. So you see this per year, and the thing is depreciate. So depreciate, it will be depreciating. Lose, that means decrease. Okay, so decrease means minus 50 every year, per year. So you can write here y or something, but it is written x is the year. So you can write here x plus, what was the starting? Starting is 500. This was fixed. Starting was $500. Okay, this is the starting. So this is our model. Okay, this is the functions. Oh, linear functions. So this is linear functions. To make it functions, what you have to do is we have to write here x, t of x. Then it is linear function. Okay. But I have we have this written here. So t of x equals to minus 50x plus 500. This is the linear model. Now graph this function from A. This is the function. How can you graph it? For graphing, we have to put some x value, then we have to put some, we will get some y value. Suppose x, then t of x. So if you put x equals to 0, your y value is 500. Yeah. And then if you put y equal to 0, you can check what is your x value. That also you can check. But you know that our total year is 10 years. So if you put 10 here for the x, then you will see this value will come 0. Just put here 10 and do the calculation. You will see then this will be 0. And if we put it in some graph for x equals to 0, y equals to 500, suppose 500 is here, and then when x equals to 10, suppose x equals to 10 is here, then y equal to 0, that means the point is here and here. So if you join them, that will be your straight line, and you can see that it is decreasing, and so it is matching with the depreciation type of thing. Okay, so this is how we can graph it. This is how we can graph it. Let's delete it, this also. This is the graph. Okay. Now another question, what is the value of the table after 4 years? So after 4 years, years means what? X, right? X. So if you put x equals to 4, what is the answer? That is the question here. So you can put here x equals to 4, then we can try it. Yeah. Then answer is $300. After 4 years, this will be $300. Interpret the slope. So we have some slope here. So what is this slope means? Interpret the slope. And this is actually very pretty much understandable. This minus 50x, it means that in every year our money will decrease by 50, decrease by 50 every year. Okay, total amount of total this money t will decrease every year by 50. T will decrease, and you can think about it from our regular slope point of view also. Our slope was what? Slope was change in y divided by change in x, right? Slope was like that, change in y divided by change in x. So in our x-axis, what is this? X-axis is years, x-axis is years. So this x means to years, and minus 50x, nothing is down, there is nothing in the denominator, that means denominator is 1 and numerator is minus 50, and this side is actually t of x is this side, t of x is this side. That means for 1 unit change in the x-axis, which is years, change in y, in this math this is our t, change in y is 50 and negative 50 it is. Or if 1 unit increases in the x-axis, in the y-axis 50 unit decreases. There are many ways actually we can say this answer. And you can write it, the value of the car decreases by 50 per year. Just this is what does it mean. The slope means this, decrease minus, there is a minus, $50 per year means down, that one. When the car's value will be $200, the car's value will be $200 when? The question is now when, that means in which year, that means you have to find out x. And the value is $200, that means t of x is $200. So put here t of x equals to 200 and find the value of x, and you will get x equals to 6. That means after 6 years the value of the thing will be $200. So it looks like I've lost Zoom. This is coming again. Although there is no student, actually I am recording everything by the Zoom application. You can see it now here. Although there is no student, because of this different types of tools that we are using here. This is kind of funny. Let me show you one very interesting thing here. I don't know, for some reason you can see this one, many of these videos, this one and this one. I mean, the point is today it is disturbing so much. I have tried it like, oh my god, again it is lost. I have tried it many times today. This one also I think. At least 6-7 times I tried today to record this class. I record this pre-record video. Every time I try, something happens. Okay, I think without this also I can continue. So this maths already we discussed. Let me show you quickly here once again. So our final answer is x equals to 6. X equals to 6. And then we can go to the next math. Next math, as I said, the next math will be also similar. So just the difference is this math, the numbers are a little bit bigger. This is 28,000 for a car, and their plan is to depreciate it in 7 years. So per year $4,000. So what will happen? The function will be minus 4,000x plus 28,000. This is the value here. Yeah, I'm back. So this is the function here, and the second question is like graph it. So we can just graph this function like this. We can put x equals to 0 and try to find out y equals to what. And after 7 years, since we know that after 7 years the total amount of money will be it will go to 0. there are some ways to understand it, because 7 into 4 equals to 28. So you can see that the line is like this. Or just if you, without thinking about this, you can just put x equals to 0, then x equals to some bigger number, let's say 4, 5, 6, like that. You should not put anything more than 7 in this math, because in 7 years total money will be total money will be covered up. So that's the thing. Then what is the value of the car after 3 years? That means we have to put 3 here. Oh, I should bring it a bit down. Okay, this is good now. I think you can see it. Yeah, now it's so after 3 years what will happen? We have to put here x equals to 3, x equals to 3, then this will come 16,000. So $16,000 will be the value of the car after 3 years. And like similar kind of question, what will be the value of the car after 3 years? What will be the value of the car? Oh, this one is this. Interpret the slope. That means it will decrease by 4,000 per year. Only difference between this math and the previous math is here the values are some big number. That's it. No other difference. When will the car be this dollar? That means now again it is the question is when. Question is time. Find out the time. Find out the value of x. X equals to what? If v of x equals to 4,000, then x equals to what? That is the question. That is the question. So yep, so we have to put v of x equals to 8,000, so put 8,000 here, then just we can do the calculation. Or use the graph. We can actually use the graph also. We can look at 4,000 is where, 4,000 is here, then where the graph will come, we can actually find it out from the graph also. If you are drawing the graph very accurately, and if you have a grid, then actually you can find it out from the graph also. Yeah, we have another example for this depreciation. Another example is this one. Similar kind of setup in 10 years. So you try to depreciate. This method you can give a try. You can give a try and then look at the answers. Just only b number is different, but other a number, c number, d number, e number, they are same. So if you are back, this is the functions. This is the functions, because if you divide it 1 to 0, then 000 by 10, then just 10 will be gone. So that means this is the number, and depreciation means minus x. This is the x is the age, and total value is 120,000. Okay. And what is the implied domain of this function found in part A? That means x value can be what to what. Implied domain means that. So you see our maximum time is 10 years. So basically from 0 to 10 years, that is the domain of this math. Because if you put 11 here, that will not make any sense. 11 will not work. 11 is not working here. Okay. If you can try putting 11 here, then you will see that some negative answer will start coming. Okay. So for this math, implied domain means according to this math, what is the domain? Or in this math, what is the domain in this math? Domain means what is the x value in this math. So age is x, and we can see that over 10 years, by 10 years actually, they will depreciate it, the whole amount. So basically the maximum is 10, and minimum, how many years it can be minimum? Minimum anything can be 0. From 0 it can be, okay, no years, that means now. Then they can say that some years, 2 years, 3 years, 4 years, but after 10 years there will be nothing. So that's why 10 is the maximum. So the domain for this math is 0 to 10. So we get the hint from this 10. Then the graph, the function, same type of thing. Then d number, what will be the value after 4 years? That means put 4 here for the x. When the value of the machine will be like this, then when means we have to find out the value of x. 72,000 is the value of v of x. Just we put them and do some calculation. Answer will come like 4 years here. There is more maths for practice. This is a review from our previous lesson, previous slide. Basically, this is from finding some linear model from the data. Actually, you have seen this. I think the problem is with the Wi-Fi. Anyway, so you have already seen, you have already solved this math, and we have detailed discussion about all these review maths. Actually, in our previous video also we have discussed this kind of maths. Here is the quick answers of this math. Then for this one you can give a try, and you can, without the answer, you can give a try, and you can try, and your answer, by the way, your answer will not be exactly same thing, answer will not be exactly same thing, but they will be close to each other, yeah? Because if you choose some other points, then the value will be slightly different. This 1.5, maybe this is 1.6 for you, maybe this is 1.3 1 point, let's say 4 3, kind of that. This number 3.5, maybe your answer may come 3.7 3.4. So it can be a little bit different, so don't worry about that, because of this is scatter diagram. For a scatter diagram this can happen, so no worries. Okay, this math also we discussed related to supply and demand, this kind of maths. Finding the model is given, then we have to find out equilibrium quantity. The same math, exact same math, just I am putting it here, we have put it here so that you have some flashback, so that you can think about it again. Same math, exact same maths. This one also same. And if you want, you can practice this one also, this kind of maths. These are the very exciting examples, very, we should say that, explicit examples of linear functions, very interesting example of linear functions. And you will see this kind of maths actually we will be able to solve by some other functions also in the coming classes. Suppose our next class will be from quadratic functions, and when we will finish couple of chapters from a couple of lessons from the quadratic functions, then you will see that this kind of math that we are discussing here now, we will solve these maths by the quadratic also, and that method is slightly different and interesting. So we have actually purpose why we are discussing this math here this way. Okay, so we will solve this similar kind of maths. Some of the maths that we are discussing here, similar kind of maths we will be solving in that quadratic part also. These are some homework. This is the quadratic chapter, so you may read in advance. That will be good if you read in advance. And then some more practice math: 37, 38, 41, 41, 42, 47, 48. These are related to straight line depreciation, supply, demand, this kind of maths, all of them. Okay, and some of them we already discussed also. These are the answers from our previous previous lesson. We said that this 25, 26, 39, and 40, that was the homework. Homework means practice work. Okay, so these are the answers. If you want, you can match your answer and check if they're right, if you have gotten them right or not. And that's the end of our today's discussion. Thank you all. Thank you very much, and see you all in the class, during the class. Bye bye everyone. Have a good time. Bye.